So we're supposed to write piecewise formulas for these functions. And what you want to look for is where the function suddenly changes. Actually, this one you could get away with using an absolute value, but they want a piecewise function, so we'll do what they want. F of x equals two pieces I see. I see this piece, and I see this piece. Changes directions. So if we're trying to figure out the formula for this piece over here, I think, yeah, the textbook labels this to reassure you that this is 1, comma 1. Okay, we want to define the leftmost piece first because we do things left to right in our world, right? So to find an equation for that, it's a line, so that means we want to use y equals mx plus b. So we need two things. We need the slope, we need the y-intercept. The slope, it starts at 0, 0 and ends at 1, 1, so the slope is a rise of 1, a run to the right 1. The slope is 1. And then the y-intercept, it crosses the y-axis at 0, so you could say plus 0 if you want, or just x is fine. That's the equation for that red line. And that red line only exists, let me see if this is an open circle. No, it's a closed dot down here. That red line only exists starting at x equals 0 and ending at x equals 1. So we could say 0 is less than or equal to x, which is less than or equal to 1. And now for this blue line, it exists between 1, comma 1 and 2, comma 0, right? So it's a negative slope. It's decreasing as we read it from left to right. So that means we would want to extrapolate where the y-intercept is. If you keep going in this pattern, look, it started at 1, comma 1 and went down to 2, comma 0. You could even use the points here to make sure you get the right slope. Plug that in your slope formula. That's negative 1 over 1. So the slope is negative 1. Okay, so we got a negative x for the blue line because the slope is negative 1. And then if you're going down 1 to the right 1, the same direction will be going up 1 to the left 1. So up to y coordinate of 2, left of x coordinate 0. This does cross at 2, comma 0. So the y-intercept is 2. So we've defined the blue line, but we need to make sure that it's only between, it starts happening at 1 on the x-axis, and then it ends at 2. And to keep it as a function, see how I use less than? I didn't use less than or equal to here because, well, it wouldn't matter. I guess it wouldn't matter because for a function, every input has to have just one output. If I put this here, the output's still the same. You know, you plug in x equals 1 up here, you get 1 for an output. You plug x equals 1 over here, you get out 1 for an output. But usually they don't let there be any sort of overlap in piecewise functions. That's it. That's a piecewise function for that graph. And for this graph over here, oh, I lost my line. I think that's what it's supposed to be. Yeah, same thing. There's two different pieces. I don't need the x and y grid there. Two different pieces, so I want two different pieces of my piecewise function. The first piece, it's always left to right. This is a line that's gone down 2 and to the right 2 to get to this point. So negative 2 over 2 means it's a slope of negative 1. And then the y-intercept is positive 2. And then we need to say where this line exists. It starts at x equals 0 and ends at x equals 2. And note that I'm not putting a line underneath for the first one because it's an open dot. And then over here, this is a new line. It starts at 2, comma 1 and it ends at 5, comma 0. So we might want to find the slope of that. 0 minus 1 over 5 minus 2. That's negative 1 over 3. So this line has a slope of negative 1/3. And then the y-intercept, it might be hard. Let's see, could we do that? No, it's not going to come out evenly. To find out the y-intercept, we got to do a little bit of algebra. Okay, we know the slope's supposed to be negative 1/3, so here's what we got so far. We don't know what the b is. So to find b, we can plug in either of these 2 points. I'm going to plug in 5, comma 0. Plug in any point that's supposed to land on this line. 0 in for y, 5 in for x. So to solve that equation, you got negative 1/3 times 5, that's negative 5/3. So you want to add 5/3 to both sides. And there we go. Now we have b. It's supposed to be 5/3. So we fully define this line now. It's this. And that only exists between x equals 2 and x equals 5. So with the piecewise function, you always define where it exists on the x-axis. There's 3 different pieces for this one, so we're going to want to have 3 pieces of our piecewise function. So f of x equals, let's make this one red. No, go back. There we go. Okay, so it's got a y-intercept of 0. This line right here crosses the y-axis at 0. And it's going down 1 to the right 1, so that's a slope of -1. And so this line exists for x-coordinates. It exists between -1 and 0. So -1 is less than or equal to x, which is less than 0. And note that this is because of a closed eye. And then let's do the next one. From here to here. So that's a straight line across, right? To make horizontal lines in math, you use y equals something. Because y equals 2, we know where that crosses the y-axis. It's right here, right? But 1, 2 also has a y-coordinate of 2. 2, 2, 3, 2. These are all dots that have y-coordinates of 2. So this makes a horizontal line. So here, the horizontal line is at y equals 1. So that's all you have to put here. Because remember, with piecewise functions, it's like you're saying y equals 1, y equals -x. So 1 is all you have to write here. It's a straight constant. And that happens between 0 on the x-axis, right? And 1 on the x-axis. So 0 is less than x, which is less than or equal to 1. And then we have a line that's going down like this. It starts at 1, 1 and ends at 3, 0. So we could plug that into your slope formula real quick to check the slope, or you could count it out, either one. So it's -1 over 2. That's a -1/2 slope. And then the y-intercept, if you aren't able to count out the y-intercept, you can plug it in, plug in the information you have into the equation of a line. Right, we got the slope, but we really want to know the y-intercept. You can plug in this point or plug in this point. Doesn't matter. I'll plug in this one. 0 in for y. Oops, that's a half. 3 for x. So 0 equals -3/2 plus b. So you're going to add 3/2 to both sides like we did in that last one. So 3/2 is our answer here for the y-intercept. And this green line exists between x equals 1 and x equals 3. So 1 is less than x. There's that double problem that we just talked about. And it's less than 3. And we keep it as less than, not less than or equal to, because it's an open circle there.